Alright, what's up guys? Starting out here, getting the base of what we're going to call the 510 connector turned down to proper dimensions, and be facing off the bottom of the deck. I was really finicky about working on this because I knew no matter which way I worked on the deck, I was not going to have much material to bite on in the lathe. It was definitely the most stressful part of the build. You can see I put a small undercut right where the 510 connects to the deck of the RDA to give the threads basically breathing room and allow the RDA to sit flush against the top of the connector, whatever connector I choose, or however I build it. I did make it oversized, and at least oversized on the length. Boring it out right now for the insulator, which will be threaded in. Bored it out to a final dimension of 29/64 for a 1/2 inch by 20 threads per inch tap. Everything's done with tap and die. It's way too easy and consistent for me to try to turn the threads on the lathe with the actual thread cutting tools. This was all done manually. I did not use the power feed or any kind of I didn't use the lathe to drive to turn the threads. It was all done manually by physically turning the head of the lathe. And here we are with the actual 510 threads with a die. It's a compression die, so you've got to actually have it compressed to the proper size. The die holder would do that, but I don't have a die holder that size, so I used a hose clamp and a pipe wrench, and it worked just fine. This is a 7/8 by 20 threads per inch. It's actually identical threads to what I used for my mechanical tube mod. The first mod that this thing will be used on will be my mechanical tube mod. It's basically going to be set up to run as a hybrid connector on that, and any connectors that I make for a mod in the future will be designed to run, or will be designed with that thread in mind. Won't be compatible with standard 510 threads. Here you can see I was test fitting it. Didn't have it compressed quite enough, so tightened it up and made another pass. And I don't remember how many passes I finally made on this, but it was quite a few. And then here we are turning it down to the proper length. I left it long for ease of putting the threads on, and I figured after that it would be much easier to turn it down on length rather than trying to turn the threads on such a short piece of metal. There I am turning that undercut again. And just putting a final finishing pass on the bottom. And then you'll see in just a second, there it is real quick. It's a terrible angle. I didn't have any way to grab the threads to turn the deck around, so I used the die to hold it in the chuck, which actually worked quite well. I was still really careful with it. had I had any issues, it would have basically ruined the part had it tried to come out of the lathe or bound up on a tool. Just face the top of the deck here, and then in just a minute we'll get started boring it out and actually deepening it and basically giving it a raised edge. I was really nervous about this part because I used the copper pins to hold the center brass in place, which this piece didn't seem to be nearly as bad. It's much tighter, but I was still really concerned about turning it too deeply, so I stopped about 25 or 30% into the copper pins. So you can still see them in the deck, but they're still mechanically functional. And went ahead and turned down this outer dimension so that it could take the O-ring groove. This is where the actual barrel fits onto the deck. The stock I had for the deck and top cap was substantially oversized compared to what I had for the barrel, but I would rather go with more material than not enough. Here we go, boring it out. As I said before, I was very nervous about this, and I could have made the lip thinner, but I wasn't sure how deep I was going to bore this out as opposed to how deep the O-ring groove would be, and I didn't want the lip to be cut off when I cut the O-ring groove. If I'd had more material, it probably wouldn't have been near as much of an issue, but that was just something I had to deal with there. And then I'll put a little chamfer on either side of that lip so that it's not too sharp. And cutting the O-ring groove in. I actually made this quite a bit more loose than the top cap fit, because I wanted to be able to pull the entire top cap and barrel off easily. Basically, the only reason I went with a separate top cap was to allow room for the allow me the material that I needed to build it properly. I didn't have enough material to build one solid top cap and barrel. Kind of stuttering over my words here for a minute. Had a heck of a time getting all that centered up, but we finally got it pretty close. And got set up, wound up turning it around anyways, and using the tailstock support to knurl that deck. And put the chamfer on, and deck was finished. Last step is to part off the barrel to the length that I wanted. And had a little issue, but it came off all fine in the end. What's up, guys? There she is. You can see a little piece of white plastic inside there. Let's see if it'll quit looking at my face for a minute here. Come on. There it goes. You can see I did turn a little bit into drilled the holes out a little too deep on these as well. That does not go through the deck, so I'll just remove the brass and call it good. Let's see if it'll focus on the knurling here. Very, very pleased with this. This actually came out much better than the top cap. This is my... I keep getting it backwards on the camera. This is my mechanical tube mod. I believe this is 27 millimeters, I think was the dimension I came out with it. So you can see compared to, it's actually larger than my, it's massive. It's huge. You'll notice the broken insulator in there. It's not actually broken. That is the final dimension for it. I have just enough sitting out the top that it holds it in place. I think I have the insulator video. I lost the video for the positive post. Both of these are effectively finished. There's still a little machine work on the positive post, basically milling it flat and putting the holes in it. But I did not get any of the footage of the positive post. I don't know what happened. It's all gone. All of it. Very, very angry, but here it is. The insulator, the diameter inside of the deck is 1/2 inch by 20 threads per inch. The inside of the insulator, this giant long threaded section, is 3/8 of an inch by 16 threads per inch. It just so happened that I had one that was fit, that was all good and the right size. So the insulator threads into the deck, and then the positive post threads into the insulator. When it is all said and done, these will be with a little bit of Loctite blue, Loctited in place right at the bottom side of the connector. And you can see I made the positive post long so that I can turn that down so that it's slightly proud of the bottom of the connector when it's done, so that I don't have any shorting issues. But you can see just how massive this actually is, as opposed to my Maximus. They're actually side by side. Focus. There is no comparison whatsoever. I could have made this post a smaller diameter, but I wanted to be able to easily fit the holes side by side. I'm still not certain I'll be able to do that. But that's 2 hours of machine work just in the insulator and the positive post. I'm very, very, very upset that I lost the video for the positive post. I don't know what happened. I'm hoping that my phone just glitched and the video's still there, but I have yet to find it. Got the Maximus on the Lysimo tonight. There it is, though. A beautiful piece of equipment. A little squeaky, but rock solid. It's like a freaking half of a dumbbell, you guys. I'm really liking how the knurling makes the, I like how the knurling stands out. Might have to contact my buddy with the CNC mill and see if we can't do some awesome engraving along the sides of this. If you guys have any ideas for engraving along the barrel, let me know. What else? What's next? Positive post is basically done. I've got a little more work on that. And then I've got both ground posts and the drip tip, and machining the outside of the positive post to proper dimensions. And it'll be ready to go. You can see how much it actually sticks out there. Do I have... I actually had one of my RDAs sitting out specifically to show you guys an actual comparison between a 22mm RDA. I don't know. I've got a heck of a mess on the work table. I've got to clean it up. I have been putting it off to work on this project. I don't have any of it yet. I'll show you guys everything when it's all said and done. And another question. This is going to get a mod. This is going to get its own dedicated mod. It will have a 7/8 by 20 threads per inch 510 connector on it, specifically for this deck. I could potentially at some point put make a adapter for a 510 thread, although there's no point. The mod is going to be way too massive to make it worth the trouble, even for the Maximus. It's going to be basically custom made specifically for this RDA. I have 2 batteries picked out, and I'm going to let you guys decide which one. And what you guys decide is going to be a vote. I don't know how the heck to set up the polls in YouTube, but I can totally set it up so that, well, I can't set anything up. I'm going to watch the comments very closely. You guys tell me which battery you want me to use. It's going to be a LiPo. It's going to be a PWM. The question is, do I go with a 3S LiPo or a 4S LiPo? 11.1 volts nominal, 12.6 full charge, or 14.8 volts nominal, 16.8 full charge. As far as the batteries go, the 3S is at 8,000 milliamp hour 40C, so 320 amps continuous at 12.6 volts. Or the 4S is a 5,000 milliamp hour 50C, so 250 amps at 16.8 volts. Really, they're pretty closely matched for total wattage output. The price difference is just astronomical. The 3S, I can get 2 of the 3S LiPos for the same price as 1 of the 4S LiPos. So I could potentially put those in series for a 6S if I just wanted to be stupid with it. You guys decide, 3S or 4S. If I have to, when it comes time to order the batteries, I will go back and I will tally up every single comment for 3S or 4S, and that'll be it. That will be the choice. Don't let me down. Don't fail me. You make the right choice. It's all up to you. I don't even trust it to sit like that. It's just too big. Yes, it's the size of my fist and it is heavy. I'm going to have to weigh it at work. We don't have a digital scale because it's pointless, but we use it to weigh our wire coils, and it does measure down to I think a half ounce or an ounce, maybe an ounce. It's an analog scale, but it's right on the freaking money. I do plan to weigh it when it's all said and done. So there's the questions. What kind of engraving should I look at getting put on the deck or on the barrel? And do I go for a 3S or 4S LiPo when it comes time to start building the mod? I hope you guys have enjoyed this. I did, was it a week ago or 2 weeks ago? I did activate the fan funding on the account on my YouTube channel. So if you guys enjoy this enough that you want to throw a couple dollars this way to help out the cause, it's much appreciated. No obligation whatsoever. I just discovered it myself and I was like, huh, that's neat. I did look into the Patreon, but I haven't looked that deep into it, and I don't really feel like it's a huge deal. What else? I know there was something else that was really important, and I say that a lot in my videos anymore. running this at exactly 176 watts because that gives me exactly 7.5 volts, which is the absolute max of this box. Oh. We have this really cool piece of equipment at work. It's called a surge tester. It's used specifically for electric motors to test the windings. It can be used for individual coils. It can be used for entire windings. It has a resistance meter in it. Does it read down to the 5th or the 6th digit? I don't even remember. Super accurate. So when it does come time to actually throw a build in this, I'm either going to use 14 or 16 gauge. It's going to be giant. So with that, I will be able to measure down, I know, to the 4th digit of the ohms of this. What is that? The 10,000th of an ohm? So I'll know without a doubt exactly what this is running, which ought to be fun. Also, once I get this operational and use it on the tube mod and ensure that it works like it should, I will make an adapter for the tube mod to connect it to the transformer, the 120 volt AC mod, and see if we can't pump out some clouds with it. That ought to be fun as well. Vape on, guys.